way. You can see my desktop, correct?
Yeah.
All right, let's see how you're doing on your these. Just go ahead and verbalize the answer, and I'll type it in.
That's 3. That is hold on, let me write.
Always know that this is going to be a small whole number. They're not going to have this problem on here where they have a 2-digit number being divided by a 2-digit number. The only time they're ever going to put that in there is if the answer is 1, 2, 3, or 4.
We did 3.
Okay.
In my head, I just took out the negative numbers and then just do it a little bit.
Yeah, that's what you should do, is you should divide the numbers and then figure out what the sign should be. That's always the way you want to do these problems.
Are those both negatives?
Yes.
All right. So that's going to be 10, negative 10. That's going to be 4.
Good. All right, let's go on. Looks like you've been doing some practicing. That's good.
Yes.
That's excellent, because you really can't go further in math until you master that. All right, let's see if we can get you closer and closer to solving these simultaneous equations. In other words, the 3 pictures I took when I was at your house. We're not quite ready for that yet. We want to make sure you can solve linear equations. A linear equation is one where the exponent on the x is 1, not 2. In other words, if this was an x squared, that would not be a linear equation. It would be a quadratic equation. Well, linear equation just means that there's one variable, it's x, and all you have to do is end up, when you solve this, with x equals some number. Okay? So that's our goal. Our goal is to get it to where it's x equals. So what's my first step?
That's 3 over 7x equals 9 plus 15, I think.
Okay. In other words, our first step is to get rid of the 9, right?
Yeah.
Okay. What is the 9 currently doing? It's being added, right?
Yeah, it's being added.
So to get rid of it, we're always going to do the opposite. We're going to subtract it. So I can look at it in 2 ways. And this is the way they teach you in school, is let's subtract 9 from both sides, and that'll get rid of it.
Yeah.
Okay, well, the other way to look at it, I mean, what's the point of expending the energy to write that right there? I know that that's going to be 0, right?
Yeah.
Okay, so why write it? The way I look at it is if I have a number that's being added to one side of the equation and I want to move it to the other side, I just move it over there and change its sign. Okay, so for me to move the plus 9 to the right side of the equation, I'm just going to do it. I'm going to write 3/7 x equals, well, it must be 15 minus 9. What's 15 minus 9?
15 minus 9?
Uh-huh.
That's 6.
Okay, so that's the next line. In other words, I moved that plus 9 to the other side of the equation. Now, I've got almost x equals, but I got this coefficient in front of x. And I can look at this as doing it in 2 steps or 1 step. the 3 is multiplying the x. The 7 is dividing it. So to get rid of this 3/7, I have to do what?
I'm not sure.
Well, let's do it first of all in 2 steps. Okay?
Right.
Let's multiply both sides by 7, because 7 is currently dividing everything.
Yeah.
So if I multiply both sides by 7, what's 7 times 6?
7 times 6 is 42.
Okay. And now I'm going to divide both sides by 3, right?
Yeah.
So I'm going to end up with x equals, and 3 goes into that once with 12 left over, so that's a 14. And I can solve it that way. Okay? So I can do the 2-step solution easy enough. Get rid of the denominator, get rid of the multiplier. But it's actually a 1-step solution here. And that's if I multiply both sides of the equation by the reciprocal, it gets rid of that 3/7 in 1 step, not 2. Notice that on the left side, the 7s cancel and replace with 1s. The 3s cancel and are replaced with 1s. And so the left side immediately becomes x whenever you multiply it by the reciprocal of this fraction. And the right side, I don't have to multiply 6 times 7 and 42 and then figure out how to divide 42 by 3. What's an easier way to do this operation on the right side? Divide top and bottom by 3.
Oh.
In other words, this 6 and this 3 I can convert to a 1 and a 2. In other words, 2 over 1 is the same as 6 over 3. And the reason it is because I'm dividing top and bottom by 3. Okay? So now my answer is just 2 times 7. Well, that was much easier than 42 divided by 3, right?
Yeah.
So always simplify before you do these multiplications. It just makes the numbers that you're dealing with lower, and lower numbers lead to higher accuracy. Notice that when I did it by multiplying by the reciprocal, 7/3, I got my answer, and the biggest number I ever had to deal with was 14. Or 15, I suppose. But I didn't have to deal with the number 42 because I did it in 1 step and I simplified it before I did it. All right, let's look at some other problems. Again, it's a linear equation because there's only one variable and it's to the 1 power. It's not squared or anything, or it's not square root of. In other words, square root of n, that would not be a linear equation. So it's got to be whatever the variable is, it's got to have an exponent of 1 for it to be a linear equation. All right, what's our first step going to be here?
Combine like terms.
Okay, so do we want to put, what do we want to put on one side of the equation and what do we want to put on the other side of the equation? In other words, combine your ends.
That's going to be 12. So should I just like put 6 on each side?
No. In other words, remember our final answer has to look like this. Equals some number. Or our final answer can look like this. and it doesn't matter. Some number can equal n. In other words, it doesn't matter whether we gather the ends on the right side or the left side. Which makes most sense here? If we gather them on the left side, how many ends do we have?
We have 5.
No, we have 5 plus, we've got to move this plus 7n to the other side of the equation. So it's going to be 5n minus 7n. How many n is that?
That's going to be a -2.
Okay, so that's negative 2n if I put it on the left. And that means I got to move this number to the right, right? Because I want to get all numbers on the other side.
Yeah.
So what's the other side?
Oh, the other side is...
It's minus 9 minus 11.
Oh, that's a positive 11?
Well, it's a positive negative 11. In other words, I can turn it into an addition problem, but I got to change the sign on the number that was being subtracted. So now I got minus 9 plus minus 11, that's minus 20.
Yeah.
Okay. Now, the last step.
Divide 2.
Divide both sides by what?
By 2.
By negative 2. That's the only thing that's going to leave me with an n. If I divide both sides by 2, I'm going to be left with a negative n. Okay, so I have to divide both sides by negative 2. What's minus 20 divided by negative 2?
Positive 10?
Yeah. So that method works just fine. But notice all the negative signs. Okay? It's really better, if you have a choice, it's better to work a problem leaving signs positive. Now, notice if in this case I decide to move this 5n to the right side of the equation, what's that give me on the right side?
12n.
No, remember you got to change the sign of it if you move it to the other side of the equation.
Is it still going to be like a negative number?
No. In other words, here's what I'm doing. I'm going to subtract 5n from the left because currently 5n is being added. You can't see it, but there's a plus sign right there. Okay, so in order to get rid of it, I got to subtract it. And then I'm going to subtract it from the other side. Well, what's 7n minus 5n?
That's going to be 2n.
Okay, so 2n. So when I move the 5n to the right side, I'm left with a positive sign on the thing. And now move the minus 9 to the left side. What do you get?
That's -2.
No, hold on. What's the 9 currently doing?
It's subtracting.
Okay, so you got to add it.
Yeah.
Or just think of, let's move that whole thing to the left side of the equation and change its sign, which means I'm going to have plus 11 plus 9.
So it's going to be positive 20.
Right. Now, the same answer, I'm going to divide both sides by 2 this time, not negative 2. And I get the same answer, n equals 10. But notice that I got it without a whole bunch of negative signs. And the only reason I did that is because I could see right off the get-go that if I move the ends to the right, they're going to stay positive. If I move this 7n to the left, it's going to be negative. Now, sometimes that doesn't matter. But in this case, it actually did matter. It made the problem easier. With fewer negative signs, you have fewer mistakes. And you can always go both ways on it. Okay, so let's talk about other linear equations. It's a good one because it's got a ton of single-digit calculations that one has to do. And this is where the importance of arithmetic skills really comes into play, because you don't want to have to do all these on a calculator. It's just too slow. So what's the first step here?
You gotta distribute the
Okay. So what's the next line? Read the next line to me.
So it's gonna be 12x minus 20
Okay, there was two calculations.
equals, is that gonna be a positive 2? Just a negative in?
Yep, negative 2 times negative x is 2x.
And then negative 2 times 8 is 16. Negative 16.
And then I still have this negative 6x over here. Okay? Now, you got a couple of choices at this point. We can combine that 2x and that negative 6x in one step before we do anything else. That maybe makes the most sense. So let's do that. What do you get when you combine the 2x and the negative 6x?
Negative 4x.
And we still have that 16. Now, which way do we want to move? Which side do we want the variable to be on? Just looking at this problem and what our next step's going to be. Do we want it to be on the left or the right?
The left.
Okay, what's it going to be?
It's gonna be 12 minus 4.
Not minus.
Or not added. Sorry.
That's a key thing. I get a number of students that they always want to do it that way. And that's why our school system teaches you to do this. They insist that you write it like that. Okay? And if that's what you need to get it done, then let's do it this way. Until you get so used to it that you'll know that it's all you have to do to move it to the other side is change its sign. Okay? This leaves no question about what the next line is when I write it like that. How many x do I have on the left?
16 next.
Okay. And I got none here. And then let's, in the same step, move this, since I've decided to move the variables to the left, let's move the numbers to the right. So what am I going to do?
You're going to add 20 both sides.
Okay, so I'm going to write it like this. And what's the right side become?
Negative 16 plus 20.
What's that number?
Negative 16 plus 20. That is 4.
Okay. And so now we have,
Divide.
so x equals 4 divided by 16. Simplify that.
And the 4 again. Thing.
What's 4 divided by 16? Is that a number less than 1 or greater than 1?
Oh, that's going to be less than 1.
Okay, so what? It's not 4 then. What must it be? Okay, here's the thing. When I give you a fraction, it's not like an equation. An equation, I can do anything I want to the left side as long as I do it to the right side. But when I'm dealing with a fraction, the only thing I can do to this fraction without changing its value is multiply or divide it by 1. That's it. Okay, well, dividing by the top by 4 and the bottom by 4 is the same as dividing by 1 or multiplying by 1, depending on how you want to look at it. What's the top? What's 4 divided by 4 equal?
Going to be 1.
And what's the bottom? 16 divided by 4.
4.
There's your answer. In other words, you had the right number, you just didn't have it in the right ratio. But it's important to think about it like that. In other words, when you have a smaller number divided by a bigger number, your answer better be less than 1. Otherwise, you've done something wrong.
Yeah.
But really what we're doing is we're merely reducing this thing by dividing the top by 4 and the bottom by 4. I could also multiply the top by 4 and the bottom by 4 and get that. But that doesn't reduce it, that expands it. So if I'm trying to reduce it, I want to divide top and bottom by the biggest number possible. In other words, reduce this answer for me. What's the biggest number I can divide the top and the bottom by?
2.
Yeah, what's the top become?
That becomes 5.
And the bottom?
That's going to become
So that's how I do it. So I'm always looking to, when I'm looking to simplify these fractions, I'm always looking for the biggest number that I can divide both the numerator and the denominator evenly by. Okay? And if I make a mistake, in other words, let's start with 12/16. And let's say, okay, well, I'm going to look at this. I can divide top and bottom by 2, right? So that becomes that. But that's not simplified because I can still divide top and bottom by 2. So 12/16, actually, I could have divided top and bottom by 4 and gotten there in one step. But if you make a mistake, it doesn't matter. You can just constantly keep having this thing until you end up with the answer. But, okay. Let's see, we got time for another one here. Okay. Which side does it make sense to put my x's on?
the left.
Well, that's going to give me a 1/3. What is it going to give me in terms of x?
1/3 x power or squared.
1/3 x what?
Squared.
No. You only square it when you're multiplying. In this case, I'm adding or subtracting. What am I doing? How do I get this x over here to the other side?
Subtract it.
Okay, so I got to do that, right?
Yeah.
And now I'm going to put my numbers on the right side, so what does that leave the right side as?
-1 or 1/6 plus 1/4.
Remember, I'm moving it to the other side. It can't be the same sign.
Oh, -1/4.
Okay. So that's what I'm left with. Now, is the left side going to be negative or positive by the time I do this operation?
Negative.
Okay. Is the right side going to be negative or positive?
Negative.
Ah. So, we probably went the wrong way.
Yeah.
Okay, let's go back and do it the other way. I can tell that if I start with an entire x and I subtract the third of an x, I've still got some positive x. So let's move this to the right side and this number here to the left side. So let's start with the left side. What have I got? I got 1/4 plus or minus 1/6?
Plus.
And on the right side, I got what? X. No. I'm moving a positive 1/3 x to the other side, so it's got to be subtracted. Okay? Now, notice that the left side is going to be a positive number because I got a positive fraction plus a positive fraction. And the right side is going to be a positive number because I got a whole piece of pie and I'm only taking away 1/3 of a piece of pie. What am I left with if I have a whole piece of pie and I take away 1/3 of a piece of pie? Okay, let's do it a different way. What would you have if you had a whole piece of pie and you took away a half?
You'd have half left.
Okay. So take away 1/3. How much do you have left?
75%.
2/3. 1 minus 1/3 is 2/3. For the same reason that 1/3 plus 2/3 is equal to a whole. However, let's do it the algebraic way. If I want to add, in other words, that's x and that's x. So I can definitely add or subtract these things. But how do I have to do it? How do you add fractions and whole numbers? Add or subtract?
Would you just put a 1 underneath each side?
Well, you want to find a least common denominator, right? Right now, there is a 1 under that. But I need its denominator to be a 3. So, how can I write this term so that it has a denominator of 3? Because that's the only way I can add or subtract stuff. There's some number of x there. How many are there?
1.
3.
3.
Notice now, the way to do these is to always backtrack and make sure that you haven't changed anything. You don't ever want to change anything. In other words, this thing here should be exactly the same as that thing there. And it is. I could cancel those 3's and end up with just x. Okay? So, my common denominator is 3. Now that I have a common denominator, I can just act on the numerators. What's 3x minus 1x?
2x.
There's still a 3 under there. So I've just shown why when you start with a whole x and you subtract 1/3 of an x, you end up with 2/3 of an x. Now, let's go to the left side. What's the common denominator going to be on the left side? Because I can't add two fractions unless I have a common denominator.
I think it's going to be common denominator is 2.
No, the common denominator needs to be divisible by both numbers. Evenly divisible. Start with the biggest one and start increasing it by 6 until you find a number that is divisible by 4.
12.
That's it. That's our common denominator. What goes here and what goes there?
1. I think it's 1.
Well, is 1/12 the same as 1/4?
No.
That's what it needs to be, is the same as 1/4. So the way you get it is you divide 4 into 12 and multiply by the numerator. What's 4 into 12?
3.
3 times 1?
3.
So 3/12 is the same as 1/4. Do the same process for 1/6. Okay. Now we have common denominators on the left side. Add those two fractions. What do you get?
Add the 2 common denominators?
No. When you have a common denominator, you just add the numerators or subtract. So that becomes 5/12.
Yeah.
Okay, and that's equal to 2/3 x. What's my final step to solve for x? In one step.
Divide.
Multiply by the reciprocal. Of which fraction? The 5/12 or the 2/3?
The
5/12. No, we're trying to get rid of that. Remember, we want our final answer to be x equals something. So I got to get rid of this 2/3. So I can get rid of the 2/3 by multiplying by what?
Multiply by. Why am I having
3/2, the reciprocal. Okay. Now I got to multiply this side by 3/2 since I multiplied the left by, or the right side by 3/2. Okay. Now notice what happens on the right. The 3's cancel, the 2's cancels. That's why when you multiply by the reciprocal, it always gets rid of it. Okay, so I've got my x. Now all I got to do is simplify that. It's the best way to simplify that. I mean, I could multiply numerators and get 15, and I could multiply denominators and get 24, but then I'd have to simplify that. Is there an easier thing I can do before doing this multiplication? What can I divide top and bottom by?
10.
No, I can't divide the top by 10. Or the bottom. How about 3? I can divide the top by 3, and I can divide 12 by 3. Okay, so if I divide the top by 3, I'm left with a 1. If I divide 12 by 3, I'm left with a 4. Now the problem becomes 5 over 2 times 4, which is 5/8. And that's the way you want to do these problems. Notice that I never dealt with a number greater than 8, or actually 12, this common denominator up here. But when you simplify before you do the math, it makes it a lot easier. You don't need calculators, you don't need any of that. But what you do have to be able to do is single-digit arithmetic. That's why I put so much emphasis on it. Because this problem alone, we probably did 12 different calculations, maybe. Starting from there, we probably had to do 12 different single-digit calculations to get to the answer. And you want to be able to do those in your head, not with a calculator.
Yeah.
All right, cool. I will let you go. I apologize. I ran over a little bit, but I did feel it was necessary to finish this problem.
Yeah, my grandma wanted to know, is there a way you can, review the sessions?
Yes, there is. Let me give you, here, give me an email address, and I will send you a link just as soon as these are done, and you can review, you can watch the recording in a YouTube file. And either give me yours or your grandmother's.
Yeah, I'll give you mine. It's chris@thedragon.com.
That's CHRIS?
Yeah.
What was the rest of it? I'm sorry?
It was at thedragon.com.
B as in boy?
Yeah, B as in boy, and then just dragon.
It's a cool last name. All right, Chris, I will send you a link so that you can watch these. What I basically have is a YouTube channel, and your file will have your initials on it. It'll be CM, and then the date. In other words, today would be your file today. Here, let me draw it on. Let me just put it up here. Your file would be, gosh, hold on. Let me erase something so I have room. Today's file is going to be CM063015. In other words, there's the date, there's your two initials. So find that file, and that will be your session. And you can go back as far as you want. In other words, we've had like, what, 3 sessions online?
Yeah.
You can review all of them. Just find the proper date that matches the session. And it does take me a while to process these. Like this file here won't be done until maybe this afternoon. As soon as I get it done, I will send you a link to it at your email address.
All right, cool.
All right. All right, Chris. Good. I think we're making progress.
Yes, sir. Thank you so much.
All right. Talk to you next time. Bye-bye.